I'm going to walk you through this article that I wrote for Block Geeks, How to Learn Solidity. I was really upset, sort of. When I got into Solidity, I did a contract for a company actually that wanted to look at doing some sort of automotive application with blockchain, and they wanted to do they hired me to do Solidity smart contract design for them. So I learned how to use the tools. I kind of cut my teeth figuring out how to use all the tools, and there was just learning how to do it was so difficult. You have to be like sort of a computer engineering master to be able to learn this shit on your own. So, and even all the tutorials out there right now are broken because they recently removed the compiler from Get. And like every tutorial was like, this is how you compile, and it no longer works. So, and it's just like, all there really is out there is like the Solidity language wiki, really. And it's very dry and technical. It's sort of like learning how to code by reading like a code appendix or something. It's hard to learn from that. So I wrote this article just so that people can kind of try to take me from 0 to 60. And so I kind of show them all the stuff I learned along the way so that they don't get stuck on all the stuff that I got stuck on. So we're going to talk about this for about half an hour. And we're going to like really run through that. And then I'm going to take you to this. I want to talk about this, all the ICOs that have been happening, and sort of how to judge them, and notes about each one, and what I think about them. We can all talk about that together. And then I have a couple slides for you on like web wallets and ICOs, and I want to talk about some of the lessons I learned working in the blockchain industry for the last 4 years. I've worked at several companies, some of them with big names, and I've learned quite a lot along the way. Okay, so, all right, let's just kind of jump in here. So if you go to Google and you just type how to learn Solidity, we're at the top. We got to the top. Amir is a genius SEO marketer for Block Geeks, and he does it all. So he paid me a little bit of money to write this article for him. Okay, so Ethereum Foundation, we just talk about sort of the Ethereum virtual machine. So the Ethereum virtual machine is, it's a Turing-complete, that's sort of what makes it different than Bitcoin, is the Turing-complete language that runs in Ethereum. And each node can execute these virtual machine contracts, the bytecode, and they all have to come to agreement. So that's one of the big things about, a lot of people don't really understand about Solidity and Ethereum's determinism, and why it has to be deterministic. So why you don't have the .random function in Solidity, for example. And the reason for that is that when a smart contract gets executed on a node, whatever node right now it's a proof of work mining system, so whatever node mines that block executes the contract, right? And then every other node that it sends out, it has to verify that block. So they all have to be able to execute that contract and agree about the state of the blockchain after it executes. If they can't come to agreement about the next block, the network could halt. It could literally stop, and they won't be able to they won't be able to agree about the next block unless it's deterministic. So that's why it's deterministic. The nodes have to be able to send the block out to all the other ones. Whoever mines it, they have to be able to come to consensus about what happened in the block, and so that's why it's deterministic. And there is actually a little bit of play there. So you could have as long as it's deterministic to the point that 2/3 of the nodes would agree, you could theoretically have a not completely deterministic smart contract.
How does block time? How is that encountered?
Yeah. So that's just one of the. You mean time when different nodes are out of sync?
Yeah.
Yeah, so that's just part of the blockchain protocol. That's just from original blockchain Bitcoin. The nodes are allowed to get about 10 seconds out of sync with each other.
In Solidity, you have access to block time, and you might have some nodes run it a second later, and they would get different output.
They should. Well, you get it's block height is what you get.
Can you grab the?
You can get the block time of old blocks that have already been mined.
Oh, okay.
Right.
Cool. Thank you.
So and then there's oracles. Oracles are one of the really coolest part because you get past this spiel of telling people that it's deterministic and you can't do anything random, and you can, and then it's like, well, am I locked into my own little world when all I can do is like look at all the transactions and like do deterministic shit? Like, no, you can actually request oracles. You can call out to an oracle. So this is sort of how it works with an oracle. So say we have an oracle and they're executing this function. They are storing ticker data onto the blockchain. So all they're doing is basically they go to the stock market and they get the open, high, low, close data, and then they just put it into the blockchain somewhere. They just store it into the blockchain. So they might do that every 10 or 15 minutes. And then your smart contract goes and looks at what the oracle said about what the stock price was, and then you can act on that. So there is this ability to act. So you can't as I said, I think here in the article, you can't write a smart contract that throws dice, but you can actually write a smart contract that reacts to the throw of the dice, as officiated by an oracle. So it is possible to incorporate stuff that's happening in the real world into your smart contracts using this oracle mechanism. And one of the things that we're looking at Ledger is actually becoming an oracle for the weather. Because when you're doing energy analysis and prediction, that all deals with the weather data, and even shipping and like jet fuel usage, all of that ties into weather data. So weather, we keep coming back to that, surprisingly. Okay, anyway. So I'm going to go back in. I'm going to jump into the code. Let's start. We'll look at this. This is the application that I built in this article. It's basically a guest list sort of page where people can go and sign. They can associate a handle and some basic like city, state, country data with an address on the blockchain. So they can basically notarize their address, and then they can actually store some images associated on their address in the blockchain. So it's like a little guestbook notary tool where you can notarize images in the blockchain. So I'm going to show you how I did that, how I built this. Okay. So we're going to start. One of the tools that we use a lot, most people in the industry are using Truffle. There are some other tools that do the same exact thing as Truffle. So if you want, in the early days of smart contracts and Solidity development, when it first came out, when Ethereum first came out, you had to sign on. You had to basically manually create all of your transactions. And like, if you wanted to deploy a smart contract that was like a transaction, it was a bytecode that you had to like create and like figure that out. It was like a pain in the ass to do anything. So that's sort of what Truffle does for you. Is that you can do these things like what we call Truffle init. Truffle is just a tool that you install with Node. You just npm install Truffle. And you can see I've installed it globally on my machine here. And then you can just go into, you make a directory and you go in there and you do Truffle init. Okay, and it generates these new folders for you: contracts, migrations, test, and this file. So it basically sort of sets up a test framework for you, where all you have to do is just write your smart contract, and you can do some simple commands to deploy and test the smart contract using Truffle. So you can see here, this is what's in the folders. Okay. So, okay, let's look at the smart contract that I wrote. I use Atom, which is just an IDE, a very, very simple, stupidly simple IDE. Okay, so the smart contract is called Geeked. Here's the structure of the smart contract. Okay, so I believe we're at higher priority. I think it's at 4.7 now, or whatever. So it's a contract, you can see. It's open contract, basically. And you get some of these nice data types like address. That's actually like an Ethereum address data type. So this geeked admin is an address variable data type. And I've got, so you can see mappings. We've got mappings. Mappings are basically just a hash. So I've got a hash which takes bytes 32, which could be an address, or it could be in this case, it's a notary hash. It's an SHA-256 hash. So you can look up things by their SHA-256 hash, and this hash will return a pointer to a notarized image. So you can see this is sort of a code pattern that I've been using, where I have a hash, and so here I'm looking things up by their SHA-256 notary hash, right? These are all the notarized images that I'm holding in my smart contract. But you can't, it's sort of hard to iterate a hash. So if I want to find out all of the images that have been notarized, I'm keeping an array here for that purpose, which is so that ends up being like white pages of all the images. So I don't have to know the hash of the image I'm looking at beforehand in order to get it. I can like find a list of all the images and then use that. Same thing with users. We can look up users by their address, which is an Ethereum address, and then same thing. This is so we don't have to know the address of every user, which we can query for a list of the white pages of all users. Okay, so we've got structs. This is basically just like a class object, struct object, and you can see I've got a string notarized image contains the URL of the image and the timestamp. And so you notice I don't actually store the SHA-256 hash of the image in the struct because you have to have that to look it up. That's like the address of the image. So we don't need to store that in the struct. Same thing with user. We've got their handle, city, image. We've got an array of images for each user that they can have an unlimited amount of, or byte 42 limited amount of images. Okay, so and then we've got contracts. This is the heart of, this is sort of the heart of, you're going to see this in every contract. It's going to be mappings and a few structs to hold the data, and then you get into your functions. This contract doesn't do any special messaging. You can also do messages where you can talk to another smart contract. I didn't do that in this one. I'll do that in the next tutorial. And then you can also do, what was I going to say? Payable contract. So we've got this one. This is a constructor. It's only called once. And this basically just sets up who the admin is. And it just says whoever initiated the contract, whoever deployed the contract, becomes the admin. That's what that does. Okay, so, and then this function is a modifier that says only the admin can do whatever function with this. You'll see here, only admin is a modifier on this remove user function. So only the admin can remove users. So that's how that works. It's a modifier. Okay, so then we have our normal functions. Remove users, remove images. Those are my censorship functions. So if people put pornography or whatever on there, I can remove it. Okay, register new users. So this is really the meat where you're going to see like the most cool stuff happen in Solidity. So and it took me a long time to figure out how to just make this like super short and just working. If you watch other tutorials, they go all over the place trying to figure this out. So one of the things that I do is do some basic check to see if the handle already exists. I don't let people overwrite handles or overwrite addresses, I guess. And then, so you can see, I just do this. I call this line right here is basically where we actually instantiate a new user. So we just call .handle onto a new user. So if we go back and look at the users object, users is a mapping. Okay, so it's a hash. So here on this line, we're just instantiating a hash by calling .handle onto it and assigning the handle. So we actually instantiate an object in the hash right there and assign it a handle with that one line. Okay. Same thing with city state. Now that this is the line that actually instantiates the user object, and then we just add the city, state, country here, and then you can see here we're actually pushing the user into our white pages. So that's where basically that's what that is. So we have the user object in our hash. We can look it up by the address, so you can see whoever creates the new user, whoever does this. Signs the guest book, they'll be asked to pay a little bit because it's actually a state changing transaction. So they'll actually have to send a little bit of ether in, and we'll pick up who that message sender was, and that address will be used as their address in the users. So when you sign this guest book, whatever address you paid from becomes your address in the user state. Same kind of thing with add image to user, very similar code here. I do some basic error checking, make sure that the account exists. I try to do some byte 32, oh yeah, make sure that the image URL is not null. Some basic error checking there, so that people can't add null images. And then again, here's the line I believe that actually instantiates the notarized image, the object in the notarized images hash using the notary hash of the image. So again, you can actually just look at an image, get its notary hash, and then query this smart contract. Do you know about this image? So it's sort of hard verification on the hashing. Okay, so that's basically it. You can look at this. This is all open source public repo. So if you look at my repos under TechTract on GitHub, I have these two open source repos here that you can look at. Okay, so that is the contract.
So it's like tracked.
TechTract. Yes. Okay, and then these are just accessor functions in here. Get users, get user, get users, and you can see. Okay, so here's an interesting thing about these functions here. These are functions. The one that say constant, those are functions that only read data out of the blockchain. Okay, so they don't change anything. They don't cost anything to call. They're free to use. So you don't have to pay to do constant functions. If you're only reading data, you don't have to pay. Now, you'll see above, these functions don't have constant. These are functions that actually change the state of data in the blockchain. So these are functions that people will be required to pay to execute. If they want to change the state of data in the blockchain, you're going to have to pay for it. These ones, constant functions, just return data, and you can see it's pretty much just return, take the user address and just give me the user handle, city, state for that address. They're pretty simple. So it's all really, I mean, Solidity is really an easy programming. There's not much to it. And in fact, it's purposely stripped down so that it stays deterministic. And so, it's EVM is supposed to be small.
Is there a way to adjust the cost?
Yes.
The amount that it takes to write data on there?
There is a way. So the gas cost, in Ethereum you pay gas, right? And there's a certain cost, Ethereum, get gas per Ethereum, or Ethereum per gas, I guess it is.
Yeah.
Right? So right now, the gas price is, in Ethereum, it's related to the block height. So the minimum gas price actually is related to block height. It goes down over time. But the problem is that the Ethereum price itself has gone up so fast that the block height hasn't kept up with it, and the price hasn't gone down fast enough. So it's getting more expensive. It's actually cost almost half a cent right now to change 1 bit on the Ethereum mainnet. 1 bit.
Wow. What's block height?
Block height is like how many blocks have been mined so far.
Okay. What was the rationale to charge for changing state? I guess I don't understand.
So yeah, and actually that's a good point because right now, you can go to. I have deployed this contract at Molecke, right? So you can go here, and there it is. Okay, so you can go here and interact with this contract, and it'll ask you to pay gas if you sign a transaction. And I'll do that in a second. But right now that you can pay gas, and the reason that you have to pay is because every node that ever downloads Ethereum from now on has to store that data and then serve it. So you're paying the node operators to do that. But the problem is that right now, if I use this contract, I'll pay $1 or something. It's 200. You'll see it's like $1 for a 200 byte transaction. The thing is that you'll put that data onto the blockchain and it'll be there permanent. For $1, I get permanent rent. So you're actually not paying for storage times time of storage. You're actually only paying for storage right now. There's no rent mechanism on Ethereum. So it's really expensive to use the Ethereum blockchain. Ethereum blockchain is sort of like a big Oracle database that anyone in the world can write to, right? And there's so much data in the world that it's going to become self-pruning. It's already becoming self-pruning because it's so expensive to use. So that's one of the reasons that we chose not to use Ethereum mainnet for our token launch, is that we don't want to be on the big global expensive ledger. And we don't even want our data to be publicly accessible. So we have a private validator network. We're dealing with energy data or healthcare data, and there has to be privacy layers in there. So everyone using one big mainnet like that is sort of, we're seeing that may not be the best idea. It may be better to have a blockchain for each industry, right? That kind of thing. So, or like you're seeing in Russia and Singapore, they forked Ethereum, and now they're underwriting their currency using some sort of ERC20 token or something. But they actually forked and they're running their own private Ethereum net because they don't want to use the mainnet either. So, okay, so let's go through this actually. Let me try and do this. I have to unlock this wallet, I believe. So I'm using MetaMask. I'm going to unplug you guys for a second so I can unlock this. So you don't get my private key here. Okay.
It's the most expensive demo I've ever seen.
I think I only have like $40 worth of Ethereum in this wallet. But it does cost a few bucks to use Ethereum. There we go. Hopefully that'll just come back. There we go. Okay, so you can see I'm using this MetaMask plugin. Now you can run, when I do testing, usually I actually run test RPC. So let me go back into the article and grab that from there. So usually you run test RPC. I go through the contract code here a little bit. Okay. Yeah. So usually I'll run test RPC with like a passphrase, a known passphrase. Okay. Yeah, and it should, every time you run it with the same passphrase, it should, it didn't like that passphrase. Try to tick instead of double tick. I had a little hard time. They keep updating. There we go. Yeah, there we go. So you can see it has the mnemonic in it. And every time, if you start it with a known mnemonic, you can get it to start with like the same addresses, wallets every time, so that you can you don't have to keep changing the addresses every time. So that's why I do that. So with test RPC, it basically pretends like it's an Ethereum node. It's not an Ethereum node, but it will. You can deploy contracts against localhost, and it'll pretend like you deployed a contract against the real Ethereum network. And then you can go and call. You can go into Truffle and call from the Truffle console some functions like give me the ABI of this contract. Let's do that. So ABI is basically like an application programmer interface. It's basically like a list of all the functions and what data types they expect and what data types they return. So you know how to interact with the contract, sort of like the programmer interface for your smart contract. And so you can use Truffle. You can read this article and learn how to run Truffle. And so usually when you're testing, you'll be running just test RPC and Truffle, and you'll just be deploying against your own little test node and testing like that. So you can do that. This tool will either connect to your localhost node. It'll try to connect to your localhost node if you have one, and if you don't have a localhost node running, it'll connect to MetaMask instead. So this is actually really cool. When I was writing this article, I was like, well, how am I going to deploy my contract? Because I don't actually have a full node running at this moment. And it's kind of expensive. It takes a while to sync a full node and all that. So I was like, I want to just deploy to the smart contract. And so MetaMask make that possible. Basically, it's a connection to a full node right in the browser. It's just a plugin, and it's actually not a bad wallet either. So I suggest my CEO just hold his Ether in his MetaMask wallet. I think it's fine. And I've worked with the MetaMask team a little bit to debug some bugs along the way too. So, okay. So if I do this, we should see connection to mainnet. And it recognizes me because I've already signed the guest book. So it sees, it's looked up my default account This is the account you'll see in my MetaMask plugin. My 501D account. It recognizes me now because it's plugged into MetaMask. So it's like, oh, welcome back. So I can add an image. Let's go and find an image. Where's an Ethereum Boulder?
Ooh, I don't know if we have any yet. Maybe on Meetup?
What comes up if we search for Ethereum Boulder?
Nerds.
Is that you?
Yeah, picture of me, yeah.
Oh my God. Well, I'm not gonna notarize.
There's
the view
Tim.
on the
You put Tim up there.
We can put Tim up there.
Yeah.
Let's do.
There's
do
Rabbit.
this.
Rabbit's on there. Rain's on there.
Oh, yeah, well,
Vitalik.
There's Rabbit. Holy crap.
That's cool.
Why am I not on here? Alright, let's do this.
Put a post on Reddit, we'll all vote it.
So this is the URL. We just copy that. And we'll stick it in here. And that should.
What prevents people from putting massive images on there?
Well, the images don't actually get stored on the blockchain, only the URL. Right?
Oh, cool. Nice.
But it would be the gas limit, because you
Interesting
can
that
store
it's
the
not-
computation.
Take that last,
So it's actually designed as a security mechanism, it's just the price went up was so unanticipated that
There we go.
sort of overrun its
Thank you.
usefulness as a security mechanism.
Okay.
Yeah.
Okay, and you can
There's-
see,
there's certain
I
size of
actually
block
did
that
this,
you-
I wrote a
So,
tool
like,
Right, yeah, okay.
so that it will actually go and check the image, it will actually calculate the image hash, and then check it against the image hash that's stored in blockchain. And give you, and so you get a little check mark to see if the image hash still matches the notarized image, right? So let's add this image. Bam. It's going to ask me for, okay, 228 bytes, 97 cents.
You could, I think, lower the gas price down to like 4 or 5 now is what miners are accepting.
Let's try it. Let's try it. 5?
5.
Then let's give it a shot.
Yeah, I think
See
we
if
did
it
that
works.
at the last Meetup. Sending a coin, it was about 25 cents, yeah.
Okay, so that's good. That reduces the price by significantly.
Yeah.
Bam. And it's gonna try and find. You may need to actually.
It could take like
It could take up to a minute. This may just have responsive because I wrote it as part of the tutorial. You may have to wait a minute and refresh.
Also, you're gonna find someone to accept it.
Right. Someone has to mine the. Hopefully that will go through. So if we go here, we can see the latest transaction from this address, and we can see it's pending. Let's see how that goes.
Is that hash from the URL?
What's that?
How are you generating that hash?
What do you mean? Oh yeah, I actually. So there's a tool within Ethereum. Oh no, I'm sorry. I actually just have a tool that just goes and looks up the hash. So I actually have a gateway, another server that this queries to get the hashes.
Does it hash the image or the URL?
The image. Yes, and that's why I had to use a separate server to do that because you can't, because of the cross refer request protocols within the browser won't let me do that.
Are you using like a T hash? Or how are you
It's just an SHA-256 standard.
You're just feeding it to like GitHub or something like that?
I can't remember which tool I used for that.
Sorry, this question might be dumb. Why is it hashing the image and it's putting the URL in the blockchain?
So you store the URL in the image. So we don't want to store all the image data because it's too big.
So you put a URL.
So we stick the URL and we look it up by the hash. So as long as
the hash of the URL.
the hash of the image.
Not that. Oh, okay.
Yeah, we store the image in the hash in the images hash by the SHA-256 hash of the image.
Okay.
So if the hash ever changes, if the image ever changes, you'll be able to know.
Okay. Okay. Cool.
Okay. So let's try this again. Did our transactions get mined? Oh, hopefully someone mined it. Hey. So okay, so you can get by with only a quarter cent per bit, or 1/12 of a cent, 1/8 of a cent per bit. That's not bad. That's better than I thought it was. Okay, so if we go back here, we should be able to refresh and we should see this. Bam. the image is too big, but whatever. And then you can actually see someone else came along and signed a notary, but they didn't have an image. But someone else actually paid to use this tool, which is kind of cool. So that's how that works. Okay, so then there's like the secret crazy bonus section of the article that I wrote. You can go through this article and it'll walk you all the way through testing and everything through how I built this. Okay, so and then at the end I was like, well, how am I going to deploy my contract? Go ahead.
Oh, I was just gonna say, I may have missed it, I came in a little late, but how is it that you're able to just adjust the gas price per transaction?
Well, as you can see, I just went into MetaMask here and I just adjusted.
You can make it 0 if you want, but no one's gonna line it.
So you're setting like a bid price or?
It's gas per Ethereum, so it's gigaway. Gigaway? Yeah, gigaway.
Like if you put $1 million in there, someone would get $1 million for doing it.
And it's actually written in the code.
No, they won't. They will refund.
So if you're actually
Yes.
coding it, you can put in a specific
pay
price,
time.
but these GUIs offer you the opportunity to just select 5 in MetaMask. Or if you're in Ethereum wallet, you have the same opportunity to choose particular gas price.
Okay. So is there
I guess if you put the gas rate wrong, if you
Is there
were
a floor?
willing to pay $1 million, then,
Well,
then
like you
they
said,
might
you
take
could
it.
use 0.
But if you just said there's like a, you have to say when you call it, there's like a maximum that you'll allow it to pay, and then it'll try and do something and may run out of gas along the way, and then it won't return your gas if it does that, by the way. But so there's a maximum, and if the maximum you set is too high and it doesn't take all that, then it'll return. It'll only take as much as it takes. So yeah, I was like frustrated because I didn't know how to deploy contracts to the actual main net. I know how to deploy them on localhost against a test RPC. That's really easy. But to actually deploy to the main net without having my own full node, right? So that's what this page is for. And there's also other pages out there now that do the same thing, like my Ethereum wallet, or there's a few other pages where you can actually just go and paste in your smart contract and just click a button like this. But for example, we can just take this smart contract and just stick it in here. And you'll see, thanks for a second. It will ignore warnings, but it won't ignore errors. And so you can see, and this is where you would adjust the gas price that you're willing to pay right there, I guess, down to 5. So to deploy this contract, that would cost, I guess, about $1.25 right now. So that's not bad. So yeah, you can use this tool. It works. You can see how the really cool part though is how I built this tool. Like go and look at the code for how this was built, because it actually this is what's really different in my tutorial from all the other articles. All the other articles tell you to compile against Geth, but the problem is that Geth doesn't. They took the compiler out of Geth. So this tool shows you how to do compilation directly in the browser client side. With this tool, no one ever needs to install Solidity ever again. Like no, you don't have to put it on your server, and they don't have to put it on their client. So it's really easy, standalone sort of tool.
Is the code for this tool on the GitHub page?
Yep, it's all open source. You can actually clone this and run it on your own server. It's like within 5 minutes. Really easy.
Are you using the Web3 Solidity?
Yep, Web3 Solidity, and I'm using browser Solidity, which is like a browserified version of Solidity, so that it runs all in the browser. And it actually loads up automatically the newest version of Solidity every time. So yeah, it's great. You can actually go into the console here and see some of the stuff that's going on. So you can see like it's injected Web3. So MetaMask injects its own Web3 connection for you. So it's object into the code. So you pick that up, and you can see like the compiled bytecode, compile and deploy call. Like you can see what version of Solidity it's using here. It picked up 4.14. So yeah, so that all works. You can kind of check that out. One thing I have been trying to figure out is how to use multi-sig wallets. Multi-sig wallet, because in Bitcoin it's like really easy to use a multi-sig wallet, but in Ethereum it's kind of hard. You have to actually deploy a multi-sig contract to the blockchain, and then you have to interact with that contract. So there's not really a good tool set for doing that right Yeah. go
Could
ahead.
you explain what a multi-sig contract is real quick?
Yeah, so it would be like if you want to have two key holders, right? And they have to both sign to move the money. Or you can do 3 out of 5. You know, so 3 out of the 5 key holders have to come together and sign. So that's what multi-sig is. So when for example, for our company, we're doing this coin token sale, and we don't want to have just one person that has access to all of the money, right? So you know, reduce the truck score of our company, basically, so that if I get killed, like we don't lose all the money, you know. Yeah, I have an interesting truck truck number story actually, for another time. So we have to, with Bitcoin, it's really easy. You know, you can do that with Electrum or Electron, I guess, with Bitcoin Cash now. But Ethereum is a sort of so let's look. I'm going to jump over to this graph of ICOs now. So let's take a look at some of all the ICOs that have been going on. When we started looking at what we wanted to do at NLedger, we're going to release a blockchain. We're going to do a blockchain project. What blockchain should we use, right? And there was all these. We kind of looked at Ethereum, Counterparty. You know, one of the reasons for us, we didn't want to use Ethereum mainly because it's proof of work, and we're an energy efficient blockchain company. We want everything we do to be energy efficient. We don't want anyone burning electricity on energy efficiency, energy chain, right? So we kind of threw out Ethereum because of that. And like I said, the Ethereum mainnet is relatively expensive to use, and it's sort of like you don't want to put all your industry data on the Ethereum mainnet, probably. We looked at Counterparty. Lisk was one that I looked at for a long time because Lisk has these Turing complete smart contracts. They're really cool. I mean, Lisk is amazing. They have basically an app. You deploy a blockchain just for your app, and like you can like serve it from the web. You can go to a website and like go to that Lisk contract, and it's like a full web app, you know, where you can interact with the blockchain. And so it's really, it kind of, to me, it was like, wow. I mean, we're getting past the point of serving the web from HTTP, and now we're going to be serving the web directly from blockchain nodes. You know, this is like a sea change. You know, this is a big change. So Lisk is a pretty amazing platform. Those guys, they have a small team, and they haven't been able to like really technically ramp up as fast as we've wanted to. So we switched over to Tendermint. Tendermint is proof of stake, energy efficient. You can use what are called Basecoin. I think they're going to change it from Basecoin. They're going to call it something else. They wrote their own version of Ethereum in Tendermint, and it's faster than the actual Ethereum network. It has a 1-second block time.
They got that from proof of stake, right?
No, they just did it. One of the things that's cool about Tendermint is that if there's no transactions, it doesn't block. So it's like latent. You know, it's really amazing. Very low bloat blockchain. So so these were my early notes. It may be difficult. It may be hard to work with. You have to kind of learn more. And with Ethereum, Tendermint is like a build your own blockchain kind of platform where they're like, okay, now you get your Eris database over here, and you get your Tendermint consensus layer over here, and like you write the layer in between. Go for it. You know, it's like that's, you know, like it's build your own blockchain. So it's a little harder to work with, but you can build a very unique, valuable, networks. They have this really cool thing called inter-blockchain protocol, where you can actually send any Tendermint currency, any Tendermint blockchains can interact. They can have multiple currencies. So I can send my energy efficiency coin onto the Cosmos Atom chain, and they just work. It just works. They all work together. And they're even getting to the point now where they're going to be able to where you can send Ether onto Tendermint chains and even Bitcoin onto Tendermint chains. Perfect side chain. And they didn't need SegWit to do it. So okay.
How do they do that if like a Bitcoin leaves the network?
Yeah, you'll have to read Jay's dissertation. It has to do with storing root Merkle hash states. Yeah, Jay's a smart guy. Okay, so we looked at Hyperledger. There's all these new ones. Hyperledger doesn't have. So there at the beginning it was like Hyperledger Fabric, Intel Ledger, Sawtooth Lake. They all merged together. They're all working on Hyperledger. IBM, Intel, Microsoft are all working together now. They have no tokens. They have no tokens in their blockchain, but they do have chain code, which is like a Turing complete language. We kind of see them as one of our competitors. MIT Enigma is a really cool project. Has this zero proof knowledge, decentralized computing thing built into it. NEM is the one that's been really taking off. And I like NEM. I think it's a good system. I like the proof of importance. So, like with Tendermint, if you want to become a validator in the Cosmos nodes, you had to like participate in the Cosmos token sale, right? You had to buy up enough Cosmos atoms that you are in one of your top 100 people, and then you can run a Tendermint validating node on the Cosmos network. So you have to have enough atoms. You have to have enough currency to be a validator in that network. With NEM, it's a little different. You put your money into your wallet, and it's like CPU proof of stake system, and then your money like vests in your wallet, and so you become a validator based on how long you've allowed, how many tokens you've allowed to vest for how long in your wallet, which I think is really innovative and a really cool system. I really like NEM. And they've got this interesting sort of, they've got good light wallet support, private chains. They've got an XEM token. It's actually not NEM, it's an XEM token. And they've got this cool delicate consensus mechanism that I think is really nice. Tezos. So there's some interesting things about Tezos. They have a permanent 5% inflation rate, right? Tezos is a lot like Ethereum, but so one of the things that happened in Ethereum, the DAO hard fork, right, where basically the Ethereum organization decided that they didn't want to allow some transactions to go through because they were like theft transactions from the DAO. But some of the group was like, well, we don't like this sort of centralized control. We don't like the Ethereum Foundation and Vitalik deciding these things and deciding to fork the community like that. And Tezos sort of has a different take on that. Tezos is like, they have a voting mechanism. So if there's ever going to be a hard fork like that, they can actually, the token holders themselves can vote on what they want to happen, and it's not like such a top-down centralized control mechanism from the Ethereum Foundation.
Didn't the Ethereum holders vote to unfork them?
I mean, I guess they did, right? They did. They voted with their hash power.
Yeah, it wasn't a hard
Well,
one.
no.
Like the vote.
No, King Vitalik got out.
So there's a lot of interesting conversations about this, and I think Vitalik actually got involved, and he was like angry about something that the Tezos team said or something. So yeah, I'm not going to get on either side of that. But they have a permanent 5% inflation, which is I don't like. I'm a hard money kind of guy. They do have their own smart contract, and then really one of the cool things that Tezos introduced is this sort of sub-language, sort of that it works with .NET and OCaml. But when you deploy a smart contract in Ethereum, only the bytecode gets actually deployed, right? But with Tezos, it's not like you can actually see a little bit more of what the code was rather than just the bytecode. So that's supposed to be one of their things that they like. Okay, and then Augur, ERC20 tokens. I don't really like these ERC20 tokens because I think they're going to die on transaction fees and state chaining fees using the mainnet. EOS launched on the ERC20, but it's going to their own blockchain. Salt is the big one here in Denver recently. Everyone probably knows the Salt team. And that's like an AML, KYC, lending, credit sort of network. So that's that. And then I'm going to talk a little bit about what it takes to launch an ICO. So this is what you don't see.
One quick question: is that document something you're willing to share?
Yeah, I'll put it up on the website on Ledger. Yeah. Oh, this is. Save it, and maybe if I open it in the right thing. Oops. Let me open that up. There we go. Okay. So yeah, running a token offering. Welcome to hell. Welcome to my hell. Oh my god. So we've been working on this for 14 months. 14 months. There's a lot behind it. You can run a token offering. You can just go to like erc20.com and like be like, my token's called ERC20 token.com, and they'll even be like, okay, here, sign up here, and well, here's your Bitcoin address, and here's your Ethereum address, and like it's like, you know, if you're gonna funnel 20 or 40 or $100 million or something, you kind of want to control the private key, you know, like that's, I don't know. There's a lot of people going after easy money, I'll say, you know, that don't really, you know, there's different levels of talent going after easy money. There's different levels of ICOs, right? So, if you want to do an ICO right, you do things like release a white paper, and you have a nice website, and you have a Slack channel, and a wiki page, and right now I'm building a login system, dealing with login security, so people can come and participate in the token sale. So all those things, like building rapport in the community, giving pitches at events, gaining traction with clients, with everyone marketing. There's all these ICO listing sites now, and they come to you and they say, for $25,000, I will run your campaign. We will put your big banner ad on our site, and we'll take, if you want to pay us with a percentage of your token instead, we'll do, like, they're like sharks. They're like, it's like there's a whole industry of these, they're like scammers almost or something. There are some good ICO listing sites. I'm not going to say that every ICO listing site is bad. Like, I like Token Market. I like ICO, what's the one? ICOrating.com is pretty good. I think those are the two that we're listed on. And press releases, like, and now it's not only press releases, like some press releases you want to avoid, like literally. But generally press releases are good. You want to do it. You got to build clientele. So with us, it's not just like a token that just, you buy the token and that's it. We have Energy Chain, and Energy Chain actually does stuff. So we're trying to build clientele in the energy industry to use Energy Chain, so people will pay for those smart contracts to do cool stuff, right? Go to conferences, and then the fact page. Like we've been going on with this fact page with our lawyers and our advisors forever. It takes so much work, and just people like pinging you on Facebook and being like, "Are you a security? Or are you what?" Like I'm the CTO. I don't want to answer questions about defensive legal terms and. But you have to do it. You have to do it. Okay, but the big thing I think, starting at the top, node incentive. This is how I judge all ICOs and all blockchain projects. Is the node incentive. What is the incentive for people to run the node? If you're going to have a private validator node like Energy Chain, it's a little different. But with a public node incentive, why would people run this node? For gas, I guess, right? So you have to look at the node incentive. What is the purpose of people running a node? Because without people running a node, you're going to be running all the nodes yourself. And it's going to be a very shaky network, basically. You need a node incentive. And the token value expectation. Why would people have any expectation that your token will hold value or go up in value? That is a serious question. And that is where people will give you flaky fucking answers. They'll be, they're like, well, we're going to give the token when you like something on our Facebook page. And I'm like, but people don't pay for likes. So where does the money come from? And why would I buy this token if you're just giving it away to people for liking something? And they're like, well, you don't understand. We're going to have the node right on the server and we'll just print the money. It's like, okay, good luck with that. What token value expectation? Like, what is the structure of your token? Why do people expect it to hold value or go up? And the node, these are serious, important questions, and these are where you should start on your blockchain project. Like, if you don't have good answers for that, you will fail. Then, technical, like setting up the Merkle tree storage and consensus layers. Are you going to use your own blockchain? Are you going to use ERC20?
Is the node incentive tied to token value expectation?
I think it is.
It's the same thing.
Yeah, it's like two sides of the same coin. Absolutely.
I might have missed this, but is there a node incentive for ERC20 tokens? It's just whether or not people are willing to pay for the gas.
The gas, yeah. It's they're like hijacking the node incentive of Ethereum, I guess. And the thing is that that makes it weaker, right? Because people are paying the gas to the node operators Ethereum,
Mhm.
right? Not to them, right? So ERC20 tokens, I'm skeptical of. We'll see where they go. Maybe maybe for some applications it'll be better than others.
Do you think there'd be an adjustment to the network that would make ERC20 tokens better?
Yeah, I think if they decoupled the gas price from the block height, which is something that we have in energy chain, allows the transactions to stay much lower in cost, that would help.
Could you define block height real quick? I know you
Yeah, the
mentioned it
number of
times.
blocks that have been mined up to right now. So since the Genesis block, I think we're at like 2 million in Bitcoin or 3 million now. I think they're at 200,000, 300,000 in Ethereum.
Sorry for interrupting all the time.
No,
Isn't proof of stake supposed to help with the gas price on the public chain of the
Yeah,
order of magnitude
yeah.
too?
So that's a thing too. Like with Bitcoin, like the more people that use it, the more high the value goes. Like
Right.
the more incentive people have to burn energy
Yeah.
to get it. With proof of stake, it's not like that. So there's a different there's a different node incentive, and it can be a lot simpler. But you still got to work. You still got to notice that anytime you there's still a rent problem, right? There's still a rent problem. The idea that you can pay one time to put data into the blockchain and it's there forever. So I think what we're kind of looking at is schemes for the ability to pay to notarize your data for 7 years, right? Or just as long as you need. And then that could also really help. And I think that Ethereum is going that way too. And that will definitely help to make their chain more cheap to use. Okay, and then finally, legal considerations. I don't know if you guys have heard of this thing called the Howey test. It's been in the news probably more recently. But this is the test that regulators use to determine whether your offering is a security or not. And not just this is just for securities, okay? That's just for securities. There's also swaps, there's also derivatives, there's also futures. Each one of those things has its own legal categories, and you can't run any of them on a blockchain. So you need to make sure that you're not, at least not a security. You can maybe skirt the line a little bit more on unregistered derivative, but you can't be a swap, you can't be a future, you can't be a security, or else you can only sell to accredited investors, right? So that would preclude you from being able to do a token sale. Possibly if you're in Singapore, you can make it work. But you won't be able to sell to US investors. So there is one called BCAP, Blockchain Capital. What's that guy's name? I keep forgetting. I can never remember the guy's name. Brock Pierce. He started this BCAP token, and they launched from Singapore. BCAP token is very clearly a security. It's a security onto their private equity trading fund at Blockchain Capital. So it tracks the value of their equity fund. That's what BCAP does, or it's supposed to do. But it's very, very, very clearly a security, and that's why they launched it from Singapore, and they didn't offer it to US investors. Okay, so that's possible if you want to move to Singapore. Then you've got to deal with advisors, your co-founders, share agreements, lawyers, investors. Investors are going to, if you want to take private equity, and you haven't launched your coin yet, the investors are going to give you a hard time about your valuation. They're going to say it's not worth how much you think it's worth. It's only worth a tenth of that. And then all this other legal bullshit, promissory notes, for your investors, which there's safe docs, which is something that came out of the Y Incubator, which is a pretty standardized promissory note. Then there's also something called Cooligo, which is sort of the newer model that I think a lot of blockchain companies are using. So you may want to look at the Cooligo promissory note is if you're trying to start a blockchain company. Financial models, pitch deck, elevator, biz plan, like all this shit takes time. This one, fucking financial model takes a ridiculous amount of time. So all these things, it's not just like, if you want to run a successful blockchain token, like it's like a full-time job for months. It's like, you gotta have a team. It's not easy. And if you want it to be successful, you don't want to go to jail over it. You gotta do all these things. Let's talk about web wallets versus normal. If you're going to be a blockchain developer, you will work on web wallets or normal wallets. Eventually, you will interface with these. If you want to be a blockchain developer, this is a good place to cut your teeth. Develop a web wallet. That's one of the first projects I did at Bridge 21. We did a web wallet. So with a web wallet, and I've sort of marked the security considerations here. This is like your normal wallet. Okay, so you have pre-compiled code that comes out of the company. They issue an executable onto their website. You can go download that executable and checksum it to make sure that it's really that code that they wanted you to run. And then you run it on your private computer. The real only security issue is if your computer is compromised, right? Or if you printed out backups, someone could get your backup statement if it's not encrypted. Your printer memory could be possibly a vulnerability. I put that. These blue stars are like not very serious vulnerabilities. So, like for example, how would you attack a system like this? You would have to actually get control of the website where the executable is issued, so that you could go there and issue a new packed executable and change the checksum, right? That might be possible. That has happened.
Keystroke logger.
It has happened. Recently, within the last year, there was one that happened to a big Windows project. The startup thing. Okay, and then you should also know where these connect to the nodes. So here, this is where you're running this thing on your computer, and it's actually connecting. If it's a light wallet, it's connecting to a node somewhere else. Someone else is running a node. If it's a full wallet, you're actually running your own full. You actually have the full blockchain on your computer, right? And you're just querying directly against that. So there's a node connection. And the node connection itself can be possibly monitored. They can't really get your private keys because it's all hashed, but they can monitor your transactions if they get control of the node. Okay, so with web wallets, let's look at it. So what do wallets do? They do signing of transactions, signing of messages maybe, address generation, keeping track of your addresses, the pool of addresses that are in your wallet. Which means in most modern wallets, this means hierarchical deterministic wallets. So you have a root key pair, and then all the other keys and public keys are derived from the root key pair. So it's like a tree of addresses. But then there's also, you can import other addresses. You gotta be careful because if you import an address into your wallet, it's not tied into your hierarchical deterministic structure, and you gotta make sure you keep the private key because it may not be in the wallet key. So tracking transactions, right? That's what wallets do. Maybe generate QR codes, right? Okay, so web wallet. What does a web wallet do? In a web wallet, the web server, all the wallet code is like JavaScript code, and it deals with libraries. Probably the Bitcore library is probably what you're going to use if you're doing a Bitcoin wallet. If it's Ethereum, you're going to do Web3. So you've got Web3 code, you've got your Bitcore code, whatever, it's all JavaScript. And it goes down, you cache it on your Cloudflare server, right? And then it goes through a TLS connection down to the client browser. So why do you use a Cloudflare server? If you're running a blockchain company, you do not want to allow people to know the IP addresses of your servers. Ever. They will attack it. Like nothing you've ever seen. You will be attacked by serious, advanced penetration specialists.
Because you're like Fort Knox.
Yeah. What's that?
It's just because you're like Fort Knox, one on the goal.
Yeah. They will attack it like crazy. And we saw that at Shapeshift. We let one of the Shapeshift servers get their IP was leaked. It was like the Cloudflare went down for 10 minutes or something one day. And the IP of one of their servers got leaked out to the public. And immediately it was like under attack, like from everyone. So that's why you use Cloudflare. Not only that, but also because Cloudflare caches the wallet code, and it represents another point of failure in the security mechanism. So then the wallet code goes down through TLS. TLS is another point of failure, by the way. The government could get TLS and forge your domain or whatever. Probably no one besides the government has the capability of doing that right now. Maybe someone at Google might be able to do it. Goes down to the client browser, and then here's the red stars on the browser again, because browsers themselves are not necessarily as secure. They don't have these secure hardware computing enclaves where they can put the private key into a secure enclave in memory, right? So if there's another program that's running and monitoring the browser memory, it may be able to snoop the private key. But that's sort of, if the client's computer is compromised, there's only so much you can do to protect them from themselves, right? So again, and then they print, the print paperback could be a vulnerability. So what would you have to do to attack this? How would you gain control of this? How could you steal people's money? You would first have to get control of the web server and Cloudflare, the Cloudflare account. Most likely, you would probably also have to get control of their, if they're running on a cloud server like AWS, you would probably also have to get control of the AWS interface. So because what happens is you'll load in a lot of the data in memory at runtime when you start up the machine on AWS, and then it won't be accessible anymore. Even if you get into the web server, you'd have to get into the AWS console to get the full keys, right? And then you'd have to get into the AWS console, which would be basically, that would give you control of the web server if you got into the AWS console. You would also have to get control of their Cloudflare, because the wallet code is cached in Cloudflare. So you would have to go into that Cloudflare and tell it to recache the code from the web server before it changes. So before you could get your hacked code onto the Cloudflare that would go out to the clients. So there's 2 or 3 points of failure there in a web server if it's built well. How do you make it stronger? Multi-sig wallets, like the Vault, like Coinbase Vault, right? They have one of the keys, and you put it into a vault, and then they have to also co-sign, so they can verify that you logged in. Everything looks copacetic before they sign. That's another way to make web wallets a little bit secure. So that's why you see like Coinbase Vault makes it more secure. Okay, so that's it. And so and if you notice, a lot of these things that you're going to be doing if you want to launch a token sale is basically the same stuff that you would do. A lot of the same stuff that you would have to do to write a web wallet. So all these, this is really important. If you're a blockchain developer, you got to know how to interface with wallets and web wallet. You're probably going to be working a lot with web wallets, unless you're like paid to work on the normal wallet by that company. Usually, most of us work on web wallets. Okay, so that's it for that. And then I wanted to talk a little bit about my experience in the industry. I was doing computational research. Let me give you a little bit of background. I was doing computational research at Rensselaer Polytechnic, and we were actually writing the testbed software for the Blue Gene supercomputers, and we were doing like simulations of airflow over space shuttles and nuclear reactor core simulations and stuff like that. So when I started, I was really interested in Bitcoin. I had been mining Bitcoin since undergrad. And since 2010, I got into it. Like the first Bitcoin I bought was like $2. My friends were like laughing at me, and now they like all come to me for financial advice. So I started. I was trying to transition into RNA folding actually. And I got into. I had a friend that started up Monetas, Johann Gavers, started up Monetas, which is a Swiss company. It's one of the first companies that was in Zurich. It was one of the very first Crypto Valley companies. And I was one of the first employees. So they hired me, and I got to work with the Swiss team. We were working on sidechains, actually, at the time. They had a triple entry accounting system that was just like Ripple. I came in as a very experienced developer, but even with 15 years of software experience and supercomputing experience, I was not the senior dev on that team. In fact, I was probably more like the junior dev. There were some others that had less experience, of course, but they were all fucking nerdy people. Like they were fucking supermans. And a lot of them were like Swiss robot types, where they were like, I don't know if you guys know Swiss culture, but they're professionals. Like they do this for a living. They're real professionals. They were software professionals, and I was a guy coming out of academia, right? And I didn't know how to use GitHub very well. I didn't know what my role in the organization was supposed to be, like if I should be piping up. And then when you're in a blockchain, when you're in a really small startup, you'll have these organization meetings where it's managers and all the dev team all in one meeting, and you kind of get to hear what the managers are talking about. As a junior dev, you want to jump in and like be like, oh no, I don't think you should do that. But if you do that as a junior dev, you will get fired. You will get fired. I have fired people because of that, because they couldn't keep their mouth shut and they wanted to be manager when they're supposed to be junior dev. And that's what they were spending their time worrying about that shit instead of doing the tasks that I've assigned to them. So, you have to know your role in the hierarchy. If you're a junior dev, your goal is to impress the other devs and become mid-level dev. If you're a mid-level dev, your role is to be a good team player and impress the senior level devs and do great work so that you become senior level dev. If you're a senior level dev, maybe you can start talking to the managers about direction and projects and all that stuff. But really, below senior level dev, you have no control over that. So that was sort of, you got to learn. Knowing GitHub will go a long way. You should know how to use GitHub and know how to do rebases, know what to do if your rebase fails because of a merge conflict, because that's what will happen the first time you get assigned to work in a team. They will assign you something, and then you'll work on it for a few days, and everyone else will push in a whole bunch of merges, and then you'll try to rebase, and you'll get a merge conflict. Guaranteed. That's what will happen the first time you try to work on a team. So you need to know what to do so that you don't get waylaid for a week, and your project doesn't get, your task doesn't get behind schedule. And so that's what happened to me. I didn't really know. It was a disparate team. They didn't really know how to use Git very well, so they were sending hot fixes with merge conflicts into the main branch. And I can bring that up. So I wrote a tutorial on how to use Git. Okay. Guide to the Git underground. I was in bed when I wrote this. And so you should know how to use Git from the command line. Like, you shouldn't be using Git from GUI because it's no good. So you need to know these things, like that's the normal Git flow, like how to merge your commit, how to squash your commits, all this stuff. And then this one talks about how to work in a team. What happens here is if a hotfix comes down with a merge conflict in it, it can actually go back down to this branch. And then everyone who's working on feature branches now has a merge conflict in code that they didn't write. And that's called rebase hell. Because it's impossible, you don't know how to solve it. There's no way for you to know how to solve it. So that's, you need to learn how to use Git if you're going to be a programmer. That was one of the wake-up calls when I started at Molecke. Okay, so I decided not to move to Zug at that time. I decided to move to Denver. And then Molecke fired everyone who wasn't in Zug or in Switzerland. I started working for Eric at Voorhees at Shapeshift. In that role, I was sort of the lead developer, but I wasn't an executive. It was interesting. I helped their team start up their Git process and helped a lot of them learn how to use Git properly. We did a lot of bringing on new coins, new exchanges, dealing with exchanges. One thing you'll notice, one thing some people don't know is that exchanges will rate limit you, but if you call them and you're like, don't rate limit me anymore, they'll be like, okay, you're not rate limited anymore. So if you're having problems with rate limit, just call the exchange and tell them not to rate limit you. So with with Shapeshift, one of the things was culture. I didn't fit in well with the culture. It was hard for me because I was sort of I was in charge of this team of developers, but I wasn't actually the manager, so my hands were sort of tied a little bit. That's a tough role. It's a tough role to be a senior dev or mid-level to senior dev. At that point, you just gotta try to be cool, try to find people that you like working with, right? Because you don't want to get up into management in a company with people that you don't like, right? So it's all about culture. Startups are harder than normal businesses. They're a lot harder. And so if you're coming into your career and you're a junior dev, you may want to consider not working for a startup because startups want you to take equity. Startups want to pay you an equity. They don't want to pay you a full salary. They want people that can take equity and like it, and not be like worried about, their financial situation. If you're first year out of college and and you need money, you're not the type of person that can afford the risk of working at a startup because they want you to take equity. You need to have a little bit of financial stability to work in a startup because you may not get paid next month, right? Sometimes I've been worried about whether my startup can pay me or not. And it's also harder because the teams are smaller and people have to wear more roles. And if you piss someone off, you could just you could blow up the entire company, or you could just be done by the next day. You could just be fired, right? Startups fire people like that. So startups, it's hard to work in a startup. It's a lot harder. People don't understand that. I think all these Code Academy kids, they teach kids that they're going to go and work for a startup and make millions of dollars, but almost no startups succeed. It's like 1 in 100. So, and you have to have good business sense, you know. So, okay, so then I worked at Bridge 21. Bridge 21 was really great. I really still like those guys. I don't know. That was my first executive role. I think as an executive, you just have to be cool. You have to sort of act like a parent. You're not allowed to get angry at people anymore. You have to sort of be tactful, and then you get into dealing with all the other shit. You get into dealing with management decisions, investor decisions. Moving up to CEO brings you away from the code, which is really hard because you're the best one at the code in the company probably. So I don't know. Bridgman was good. I still hang out with Will Madden. He's a great guy. And so let me talk about a ledger for a minute. We are doing just basically a blockchain portal. So you can see I've already got some Ethereum tools up here. And right now I'm building the login system so that you can buy an energy efficiency plan. So yeah, join our Slack. We actually have blog articles. I do that every few days. I put up some blog articles. So yeah, check out our tech. Check out our EV coin sale. And thanks for letting me be here. Thanks for learning. If you guys have questions about code, I'll stick around and we can talk code or whatever.
I have a question about how do you handle like deploying updates to like a contract, like code if you find a vulnerability and use old code or something like that?
Yeah, that happened to one of the startups this week. And it cost them like $15,000 to roll it over because you can't really rewrite, you can't really update. You just have to like. I think it was Augur. I think you're right. And they discovered that there was some old vulnerability because they had written their smart contract in Serpent, not in Solidity, and so you just have to redeploy it, and you have to like move all the funds to the new one.
So there's no update, you just rewrite it, redeploy it.
Yeah.
For now.
For now, yeah.
There are ways to write a function, like tricky function.
Like a workaround.
In your contract, like what's the name of this function, which is the parentheses?
So it forwards along the calls, and one of the contracts is upgradable, and the other one is just the data sort. Is that what you mean?
Yeah, or like this was so there's like a fallback function that just accepts bytes and then does this like delegate call thing. And Parity had this in their multi-sig wallet, which is what caused this $30 million exploit. Which is it's a really cool function, but they forgot to put one word inside of it.
Only owner.
Yeah.
Yeah.
They did have someone audit that.
Yeah, and like if you look at the standard Ethereum multi-sig contract, it's actually like 4 contracts that work together. That's actually what makes it a little tricky to deal with because the Ethereum wallet doesn't pick up the right one. So I may end up writing another tool just to work with Ethereum multi-sig wallets and just put it on our site, just to make it easy for people and easier for ourselves. But I think what we'll end up doing is having like a full clone of my Ether wallet eventually at Ledger. So
Do you use events much?
we have some tools. What's that?
Do you use events?
Oh yeah, events. So events is a cool thing. So if you look at if you go into one of these functions, you can add like a function that's called an event, and it's like a socket push basically. So if you have like something in here that says like call this event, like right here you would have something like do event. That's like a function, right? So then anytime someone is on the web page, they can actually be tracking this smart contract and watching events on the smart contract, so that they don't have to like refresh the page. They can actually you can actually push events down to the page like a socket basically. Yeah, so that's in the next tutorial. Events and messages. Messages is so that's what a DAO is. It's basically just a smart contract that can message another smart contract. contract and react to it. That's a DAO. You know, people get really confused over what the hell a DAO is, and it's really just a smart contract that can talk to other smart contracts. Okay.
Any other questions? Kevin?
Yeah, I was curious, we talked a little bit about tools in the beginning, but I don't know if we covered this specifically. What do you use to track code coverage for your truffle repos?
I don't know. I don't actually do
Okay.
that. There is a test folder.
Yeah, I've been using Sol Cover, but it's not perfect, so I'm looking for something else.
Yeah, you can see when you start up a contract, it just starts these folders for you, right? I guess test is not one of the folders. I'm not sure how you do that.
Are you test driving your development when you're building, or?
I just test by sending coins.
Okay, cool. I didn't mean not to sound judgy. I was just asking.
I do. I need to spend more time. You know, testing is always like the last thing. It's always like the last, least prioritized, most important thing on the list.
Right. Sure. Well, I was thinking like the smart contracts, if they're immutable, if there's a bug, the cost is way higher. You know. So.
Yeah. Well, I'm worried about the Ethereum smart contract. I'm worried about the Bitcoins. You know, that we're taking in. We're just going to try to reap that all into the exchanges probably as soon as possible. And we want, you know, one thing that happened recently is like all these Ethereum token sales, right? And all these token sales came out, and they all accepted Bitcoin and Ethereum. And like Bancorp, for example, they raised $1 billion, right? And their market cap is like 70 million. And like, where did all the money go? Like, did they just take $1 billion out of the Ethereum market cap? Kind of seems like maybe they did. So, you know, we would like to be able to run our ICO in a way that we don't have to just sell every token that we take immediately onto the market, right? But as a small company, we don't have very much risk tolerance, you know. So we're looking at options, to probably take some options that would protect us from crashes, that kind of thing. But you know, it'd be good if the companies would try to not just sell all the tokens they take right away. And we're hoping that eventually people will be able to take more like other tokens too, like 10 tokens. You know, you'll be able to take 10 tokens for your ICO. We looked at trying to accept dollars, but it's really hard.
Well, there's so many KYC.
Yeah, we would only be able to, and also it's reversible, right?
Yeah.
So we would only be able to accept bank wires from people that we had AML KYC.
Right.
So we're trying to find a partner who will help us with that.
Could you not utilize Shapeshift to accept any of their?
Yeah, we could. In fact,
they
I
have
know
a
the
plug- they have a
affiliate
plug-in
program for
button,
Shapeshift, so
HTML
I know
button.
just how it works.
Yeah.
Do you know how Circle did? They did an AML KYC token sale.
Yeah, and I'm sure that's because they already have an AML KYC platform that they built, right? So it's easy for them. We're looking at Bridge 21. Maybe we'll work with Bridge 21. We're trying. Maybe Kraken can help us. I'm not sure. Poloniex reached out to us, and eCoin is going to go on Poloniex.
Sounds like they're having some issues right now.
Is that right?
They just changed their user services and they went down for like 4 hours yesterday. Like,
I was nervous about it, honestly. I was nervous about Poloniex because I had heard that maybe they were running on fractional reserve or people weren't
so
getting
one of the terms and conditions or something
cashed
is that no
out
one
on
can do a
time.
class action lawsuit.
I don't know, because if we put our token on there, we're probably going to have to hold
It was the first
hundreds of
term
thousands of dollars
no class action lawsuit.
on Poloniex. But I talked to Eric a couple nights ago, and he was like, "Yeah, I trust the Poloniex guys." He laughed when I told him $300,000. So yeah,
What was 300K?
if we put eCoin onto Poloniex, then we're going to probably have to hold at least somewhere in the range of 300K on that exchange, because eCoin is a pegged asset. We need to maintain the peg. That's actually part of our profit strategy. The peg is our profit strategy, so that's how we make money.
We're talking about web-based wallets. How does I guess the iOS developer or Android developer?
Right. So iOS is a whole nother. I was thinking about putting that on there. I talked to the Breadwallet. Actually, the CEO of Breadwallet lives in Denver, and we've met with those guys. They have probably the best iPhone wallet right now, Breadwallet.
For Bitcoin.
For Bitcoin, yeah. And the Jax wallet, I would recommend not using. It has a security vulnerability that's pretty severe. So, yeah, and that's all. You're going to be writing, what's the language? It's going to be React Native or Swift, right? Objective-C. So there are libraries. And I believe the Redwall team wrote some of those libraries. So yeah, there's libraries. It's a different security model. But the cool thing about iPhones is that they actually do have a security enclave where you can hold the private keys in like a secure area that can only be like unlocked if they unlock it with their thumbprint or whatever, right?
What about like I guess MetaMask needs to interact with smart contracts?
Yeah, so I use MetaMask to interact with my smart contracts here. If you have like an Ethereum web page that runs on Web3, it needs a node connection somewhere, right? So you would either have to run like a node, an Ethereum node at your website, and then connect. But that's sort of a vulnerability to run an open node, right? You don't necessarily just want to like put up AWS and stick an Ethereum node on it and leave it open to the public. That you'd probably get DDoS and run up crazy usage charges and stuff. So you don't necessarily just want to leave a node open to the world necessarily.
Are you actually in a mobile browser?
Yeah.
Or
So like say I'm trying to develop a decentralized application, but I don't want it to just be web-based, and I don't know how to use MetaMask on an iOS device.
Right. So with that, you would build it. You would probably have like a light client that would connect to your own server. Like in Bitcores. Bitcore is a library of a bunch of code for doing JavaScript stuff like figuring out addresses and tracking wallet code and all that shit. But then part of Bitcore is the insight node, which you have to run an insight node and connect your Bitcore code to an insight node. So there's you have to either run a full node, probably you're running a full node that the earphones will connect to, and then it'll be just like hard coded. The address of your node will be somehow hard coded into your app and kept secret or whatever. Or there might be some sort of security login protocol that it has, so that the outside world can't just access your node.
You may also want to check out Status. I know that they recently released a development. It's basically designed to manage all like the shit that you don't care about, so that you can just focus on your user experience. I think I haven't used it.
So it's kind of
Yeah, if you're interested in iPhone wallet dev, you should talk to the Redwall guys. They might hire you.
Can you comment on the Jets?
Yeah, that's pretty bad, man. That's really bad.
You allude to what's happening.
So Jax has this problem in their code where the private keys are not stored; they're stored in plain text in a file, right?
Because of how they write it for like Chrome extension, they have to write it for everything.
I guess I'm not sure if it needs to be that way because of the architecture of how it was. I mean, one thing that happened was after it was pointed out that the wallet developers stated that they weren't going to fix it. So that's a real problem. Like that means that wallet is severely less secure than all other wallets.
So would you use you conceivably use the PIN that you use to unlock the wallet to essentially encrypt that blob?
All you would need is an app running on that phone to get their private key.
No, but like if you wanted to create this fix for them, you would just encrypt that kind of blob with all your private
Right,
key.
yeah, you would add like a password or a thumbprint layer, and then you would encrypt the private key with that
It'd be easy
password.
for them to fix it.
It would be easy for them to fix it.
They clearly have a motive to where they don't want to fix it.
Apparently, over $400,000 worth of user funds have been lost due to that
I'm sure there's a different backdoor too that no one knows about.
So it's pretty bad. Don't use Jack's wallet. And if you write a wallet, make sure that you store the keys encrypted.
I mean, Jets is like a really, just don't put a lot of money on Jets. It's a really cool wallet that
Right.
has the shape configuration that
Right.
covers a bunch of coins. But don't put your Fort Knox on it.
If you're gonna just go out to get some beers with your buddies,
Yeah.
that would be fun. Probably.
We used it for a charity project with homeless people, and they were dealing with like $10.
Right. Yeah, it's probably fine for any under $100 or something. You don't, like your wallet, normal wallet.
You have to have someone snooping on the network to even find
Your-
it's
your
not.
Well, yeah. So the way that
it's not like over the
they
internet
would
tap.
have to. one thing that hackers will do is go to hotels and hijack the Wi-Fi access points and wait for people to try and install apps, and they'll inject pirated code into any app that's trying to download. And then if you get a pirated app on your phone, that could easily take your Jack's money. That sucks. I don't know what those guys are thinking. So yeah, I don't know. I'm gonna have another beer. Stick around for a while. If you got code questions, let's talk about them.
Thank you.
Yeah, cool. Great.
So.
No, you were going.
Yeah, I was thinking about that. Like, so,